Now, second part of the lesson we're going to start off with is we had the original formula. A equals P times 1 plus R over N to the NT for compound interest. What I'm saying is we're going to invest $1 at 100% interest. After the first year, if we do it annually, what's my principal? How much am I investing? $1. 1 plus, what's my rate? 1. Because 100% means 1. Happens annually. 1 times 1 for 1 year. One plus 1 is 2. 2 to the first is 2, and 2 times 1 is 2. So annually, I have $2. You doubled your investment. Now quarterly, I want you to go through and find out how much would you have quarterly, daily, hourly, and every second. So what's going to change in this problem is your N for all 4 of those. All right, for the first part, for quarterly, all I'm going to do for quarterly, it's going to be 1 plus 1 divided by 4 to the 4th, which I get 2.441. Okay, daily. How many days are there in a year? So I'm going to change this number here to 365. And I'll change this one here to 365. 2.715. So this means quarterly you'd end up with $2.44. This one would be $2.72. For hourly, I am not going to sit here and find out how many hours. I'm going to let the calculator do the work. $60. Actually, how many hours are there in a day? 24 times 365. I'm going to take 365 times 24. I just put the numbers in there. 24 hours in a day, 365 days in a year. Hit enter. $2.72. Now seconds. I'm going to do the exact same thing. Now, for secondly, every second. How many hours, or how many minutes are there in an hour? 60. So times by 60. How many seconds are there in an hour? Or sorry, how many seconds are there in a minute? 60. I'm letting the calculator do the work. Times 60, times 60. Whoops. I messed up here. There he goes. 2.718. What do you notice? It's not the exact same thing, but it's close every single time. About what number is it rounding to? 2.718. If I even made this number larger, it's going to go to the same thing. That number means something. We use this for a continuous compounding interest formula. This is the formula for compounding continuously. This is the one that was mentioned Friday in class. PERT. A equals P times E to the RT. A stands for the total amount. P stands for the principal, the original amount. R stands for the rate. T stands for the time. The one thing I did not mention anything about is the E. E is an actual number on the calculator. It's right next to the 4 in yellow. So second ln gives me e to the. If I do e to the first, look what number it gets me. E just means 2.718. Yada, yada, yada. So some of the problems we had Friday, we couldn't finish because we didn't know the continuous formula. Here's another formula. Radioactive decay. D of t equals p times 0.5 to the x divided by h. P is the original amount of the substance at x equals 0. So P stands for the amount of whatever left if it's still intact. H stands for the half-life. Half-life is how long it takes something to decay in half. Here's an example. When a living organism dies, its carbon-14 decays exponentially. An archaeologist determines that the skeleton of a mastodon has lost 64% of its carbon-14. The half-life of carbon is 5,730 years. Estimate how long ago the mastodon died. What is a mastodon? What is a mastodon? It's a dinosaur. What does it look like? I had one as a pet. It's like a woolly mammoth. This does not mean that all the carbon's gone after 5,000 years. This just means that there's half of it left. This is accurate. This is actually the way they figure out how old things are. All right. We know that there is how much of the mastodon left? How much is left? The mastodon is 36% of whatever he started off with. What? 36 lost 64%. So there's 36% of it left. And I know that d of t equals p times 0.5 to the x over 573 5730. These two are going to be equal to one another. So all I'm going to do, set that equal to one another, and then we're going to solve. What's the first thing that'll happen? The p's will cancel out. Now, to solve it from here, we're going to use the calculators. Just like we did on the last one. 0.36 in the first line. In the second line, I'm going to put the equation. 0.5 to the x divided by 5730. First one's just what the mastodon has left. This one's the formula for half-lives. Yes? Nope. If I do zoom 6, really don't see much, right? Except for 2 straight lines. Let's think for a second. What is this problem talking about? The death of, okay, a mastodon, which is a dinosaur which lived thousands of years ago. Like, how long ago? 2000. We're in the year 2011. So we might need to look a little bit further back then. So we know it's more than 2000, right? I'll just use, I'm going to change my window. Okay, I know you can't have negative. And I'm just going to go to, I'm just going to throw some zeros on. 10,000. I know dinosaurs did not live 10,000 years ago. Or they might have. I'm just going to try 10,000, see what happens. All right, 10,000. Let me change my... All right, there's the one, and it's sort of, it's hard to see. There's the first line, the second line's there also. Let me just, there's both graphs. I don't really need to see where they intersect. It just needs to be on my screen. Second, trace, 5 for intersect, enter, enter, enter. The intersection point is 8445.6. That is how old the mastodon is approximately. 8,445 years old, approximately. No.